I want to show an alternate method besides using factor trees and prime factorization to find the greatest common factor of two numbers. Now I picked two numbers that were kind of big just so we couldn't obviously see what the greatest common factors were without doing the work here. So what I'm going to do is take these numbers and what I allow is anything that I can divide both of these by must be part of their greatest common factor. So, for example, I can see that both of these are divisible by 10. Okay, I'm super abusing notation here, but these are both divisible by 10. This would be 2,772. This would be 468. Now, you have to keep going until you are sure you've found all of the pieces of the prime factors. So see, notice I just have the quotients left here. Now I'm looking for a number that goes into both 2,772 and 468. Now it might be easy to do 2, and you can certainly go easy, but notice that 2 plus 7 plus 7 plus 2 is 18, so this number is divisible by 9. And 4 plus 6 plus 8 is 18, so that number is divisible by 9. I'm going to divide both of these by 9, so that would give me 3, 0, 8. This would give me 9 times 5 is 45, so 18 left over is 2. Okay, now I can see that both of these guys are divisible by 4, because the last two digits of each is divisible by 4. 308 divided by 4, let's see. 3 goes into 30 7 times for 28, and 7 times for 28 again. 4 goes into 52, 1 for 40, and then 3 more for 12. Okay, 13 is prime, 77 is 7 times 11, so I'm done. The greatest common factor of these two numbers is 10 times 9 times 4, which is 360. So there is an alternate method to give you the greatest common factor. Take each of your numbers, divide them by things that you know you can divide them both by, and then keep working through the quotients until you get to a point where you can tell whatever's left is relatively prime. Whatever's left does not share any factors.